A very good evening, everyone. So, the week 11 of the course of the Crystal Symmetry and Tensor has been over. So, we can discuss the numerical based on that. We can discuss your doubts based on that. Okay. So, let's get started with that. Share my screen. Yeah. So, in this particular week, what the content that we have discussed, let's have a look on that. Here, more or less, the entire week content was to understand the international table, to interpret the information, how one can read the international table. So the international table consists of the headlines, symmetry diagram, general position diagram, and the location of the origin has been mentioned over there. Asymmetric unit will be there, which is from the lecture itself we got to know that yeah it is different from the unit cell. And then we understand about the symmetry operation that and how the symmetry operation can be written. We are going to solve numerical based on that. We will solve a few questions so that we are get more familiar with the things. Then we discuss about the generator selected and in the lecture the position, which is like side symmetry, Wyckoff positions, all those things, and the coordinates. Those will be mentioned over here. Then the position of the coordinate triplet, how one can write the coordinate triplet in the form of the symmetry transformation matrix. Okay, so based on all this content which we have learned so far in this particular week, we'll solve few questions. Let's go with the question number one. Okay, so now the question number one is telling that we have to write a point group of the space group. This particular space group is given to us. There are two space group A, small a, capital 2, and there is another one P, 4 2, N. So corresponding to this space group, we need to write their point group, respective point group. Right. So the first rule is that we need to we will eliminate whatever the centering information is given to us that has been eliminated. If there is a glide, we'll convert it to the mirror. If there is a screw, we'll directly convert it to the rotation. Okay, whatever the fold of rotation it is given. So E, we know that it is a glide. So we'll write M. A is again a glide. We'll write M. And 2 is a two-fold of rotation. So we can write them as it is. So the point group corresponding to the space group of AE, A2 is MM2. Similarly, following the same thing, we go with the second one also. We already eliminated the first part, that is it is telling about the centering part. Then the 4 2 is a screw, and we know that if there is a screw, we'll directly write them in the form of the whatever the fold of rotation they are having. So this is 4 fold of rotation. 4. Then there is a N, which is a glide, which will be written as the mirror M. Then there is a mirror, we can write. And so the point group of P4 to NM will be 4 mm. So with that, just keeping in mind that we need to convert the glide to the mirror and the screw to the simple rotation and eliminating the information of the centering, we can solve this particular question. Okay. So if there is any doubt, please ask me. If there is no, let's move to the next question, question number two. So what this question is asking us: for a space group C 2 to 2. So the question is that space group is given C 2 2 2. We need to draw the general position diagram. We need to draw the symmetry diagram, and then we have to list down the symmetry operations. These are the things that we need to do. Okay, so we'll do all of them simultaneously. Okay, so let's start with the general position diagram. C is telling us that there is a centering is there. Okay, so let me make a partitions. Just for the reference line, I'm dividing them in the two parts. Okay, here we are going to draw the general position diagram. And here we'll draw the symmetry diagram. And let us say somewhere over here, we'll write the symmetry operations, lists of symmetry operation. So let us say since this is C center, we are starting with the first point. Let us say point is over here and it is shifted by the amount of sum in the Z direction. So this is our A, this is B, and the origin is lying somewhere over here. This is our origin. So what 2 to 2 means? This point group we have already known. This point group we already know that there's a twofold about the C, twofold about the A, and twofold about the B, and twofold is about the A. So if I follow there is a twofold about the C, so we can add this twofold over here. Centering is no more different. So this point will be as it is reflected over here, will get over here, and twofold will also be about this particular axis. Okay. Now, how one can get the first point itself? The one can get the first point just by the one fold of rotation, right? So if I write symmetry operation over here, so the first point one can get just by the one fold of rotation that we have wrote over here. Okay. Now let us say about the C axis, we are going to rotate. One thing is that we don't write the symbols in the general position diagram. This is my mistake, that one shouldn't write the what twofold, whether twofold is there or what is there. We shouldn't write that. So let's side by side, let me make a symmetry diagram. So we have got that, okay, yeah, there is a twofold over here. Twofold over here. and at the center there is a twofold. Then we are this is going to rotate over here. Let us say we have from here we have got to the after the twofold rotation we get to this particular point. They are just going to rotate. Now there is a twofold also across the A axis and B axis. So let us say I am rotating the things about the A axis. About this axis if I am rotating. Right. So how do we represent the twofold across the A axis? So we can simply make this particular arrow in the general position diagram, and we can say that yeah there will be a twofold over here. So similarly also here also. This lattice point is no more different from this lattice point, so we can write over here. So after doing that, what we'll get, this point will be reflected back, plus we'll get to the minus, right? It will just go to the bottom. Like rotation by 180 degree from here, if I rotate it from the top, it is going to the bottom. So considering this part to be the top and this part to be the bottom. So the plus will get to the minus over here. And similarly also here also it will happen. It will happen to all the points, right? And so this point also will happen. Plus will get to the minus. One thing which we know that all these two folds, when they are combined, when they interact with the translation, lattice translation, they produce the additional twofold at their center. So in between this, there will be a twofold. In between this also there will be a twofold. So here also it will be there, and here. Diagonally also, interaction of these two with the lattice translation will get the twofold over here. We'll get twofold over here. Right. Now, let's try to write the symmetry equations for corresponding to each of them. From here, we got to this particular point by the, let us say we can say that, yeah, from here we can get to this by the twofold of rotation. But the rotation was about the which axis? We know that it was about the z axis, right? It was about the z axis. So we can write them as a O, O, Z. Right. So this we are writing for this particular this sets over here. Now, what about the third point? How one can get this particular point? Starting from this particular point, let us say, okay, we can rotate them by the axis about this particular axis. This axis is nothing but a b axis. Okay, y axis. There is a twofold is there about the y axis. O, O, Y, O. Now, what about how one can get this particular point? Starting from this point itself. It can be done by this particular rotation, right? So we can write that there will be a twofold which is along this particular axis about the x-axis. X, O. So first part is telling that the what's out of rotation, and the second part here is telling that where that particular symmetry element is lying. Whether it's x-axis is a twofold rotation, y-axis is a twofold rotation, or z-axis is a twofold rotation. Right. Then now let me add this also that yeah there is a twofold which is along the y-axis. There is a twofold over here. There is a twofold over here. So this centering is no more different from this particular axis, from this particular point. Now, now we need to think that from considering this particular point number, this particular point, how one can generate this particular point. So this is followed by the just a simple translation, right? So now this we have done for the set of OOO set. So we'll call this particular to be this particular set to be the OOO set, and this particular set to be the half of zero set, right? So you have done for the OOO set. Now we need to go for the half half O set. Okay. So now let us say how one can go from this particular point number one to this particular point, right? So this can be done just by the simple translation. Translation is by the 1 by 2, 1 by 2, and 1 by 2. So we can write the translation will be there, and translation will be by the amount of 1 by 2 along the x-axis and the 1 by 2 along the y-axis. And along the z we are not going to move because the position along the z are exactly same for both of them. Now think about this particular point. How one can obtain this red plus point. Instead of that, first let's go with this particular point. Okay, let's complete it out. How one can obtain this particular point? So we can say that okay, there's a twofold rotation over here, which can translate this particular point to this particular point, which will just move this particular point over here. So followed by this particular rotation, twofold rotation, right? Now the thing is that where this particular twofold is lying. So the 6 point, if I talk about, there is a twofold is there, but what is the location of this particular twofold? The twofold is lying at 1 by 4 of the x and 1 by 4 of the y. I shouldn't write in the bracket. 1 by 4 of the x and 1 by 4 along the y. And about the z, it can be anything. So we can write to be that it as z. So with that, we can produce this particular point itself. So we got these two also. Now let's talk about this particular points, these 2 points, how one can generate them. Starting with this question. So let's take a new page. I'm just writing them as it is. So now our question is that how one can generate, let us say, this particular point from here, right? So this can only be done by the screw. If I rotate about this particular axis by 120 degree, this plus will go to the bottom. This upside will go will follow the 240 sorry 180-degree rotation. It will go to the bottom. Will take a minus sign. But then it has to be rotated. Then it has to be translated also by the amount of, if this is a b, entire is a b, it should be translated by the amount of b by 2, right? So we can say that yeah. So here there is a screw is there. So we can, in our general position diagram, so here it will be a screw axis is there. So how we can write that it will be screw will be rotated by the half arrow. Here also we can say that yeah, it will be rotated by the half arrow. Similarly, here also there will be a screw. So on and so forth. One can get this. So what we can say that Now, where this particular screw, how to write the symmetry operation for this? So we can say that yeah, it is a twofold is there, but it is followed by the translation. Translation is by the amount of along the y-axis, along the y, right? So we can say that for x we are not going to translate by any amount. In y we are going to translate by the 1 by 2, and in z we are not going to translate. So in this bracket we write the translation part, rotation, then the translation, and then it is followed by the like what this particular like where what is the position of this particular screw axis. Okay, so for the position we can say that okay it is lying over here. So how do we define this particular thing? So we can say that x is at the 1 by 4, y is okay. I shouldn't write this particular bracket again. Y can be anything, and z over here in this particular diagram z is 0. Okay, so we can write them as it is over here. 2 fold is there with the translation of O 1 by 2 O, and there is a location of this particular axis is along this. Similarly, how one can obtain this particular point, we can see that yeah, okay, there will be the screw. There is a screw which is corresponding to over here. So if I take the screw over here, it is going to rotate this to this particular point. Plus will get to the minus, and then translate by the amount of a by 2. Right. So similarly, one can write for the 8 also. Let me write it over here. So this is a screw axis. So here what we can see that there's a twofold is there, screw is there. So screw we will write the along with the twofold we'll write the translation part also. So the translation is by in the x direction is by the 1 by 2 and then 0. So in z direction, in y direction we are not translating by any amount, and so in the z direction also. Now we will write about the location of this particular axis. So along the x, from the x it is shifted. From the x it can take any value, right? So we'll write them as it is, like it is x. About the y, it is shifted by the amount of 1 by 2, right? So sorry, 1 by 4. So we will write 1 by 4, and the z is 0 as it is. So this is what it is. Okay, so with that we have completed this entire part, that we have listed down the general position diagram, we draw the symmetry diagram, and also the list of the symmetry operation. So this is how one can do it. Okay, so it's always favorable that if you do all the things simultaneously, you will get more information. Like you will keep on building the things. Okay, so now if there is any doubt, please ask me. Meanwhile, let's if there is no, then let's move to the next question, question number 3. For this question, so this question is telling that we have to find the side symmetry of the origin. Okay, we have to find the side symmetry of the origin. So origin, let us say, yeah, this is the listed is there that okay, yeah, this is origin. It's marked over here. It's marked over here also. That this is origin. Okay, so this is a symmetry diagram itself. So it's very easy to know the origin from this particular diagram. Let us say how. Let's try the first question. So this is P22. So we got to know that it is P22. So this is a orthogonal system, right? And we know in the orthogonal system, its viewing direction is A, B, and C. So about the A, we'll see what kind of symmetry element A is holding, what B is holding, and what C is holding from the origin. Okay, so we can see that there is a fold of rotation is there along the A. So this arrow is indication that there is a fold of rotation and it is twofold. So we can write that first position among three positions. We can write that origin in the this particular direction. It is a twofold is there. Along the Z direction, sorry, along the Y direction there is again a twofold, and along the Z direction there is again a twofold is there. This this mark itself is its indication that along the Z direction there is a twofold. So the origin is lying at the intersection at this particular point. So this particular point is having the side symmetry of 2 to 2, right? So this point is having all these particular symmetry elements. Similarly, see here the important thing is that the arrow, how the arrow is representing over here. If we go with the second question, it is P 2221. So again we got to know that this is orthogonal. So about the origin is marked over here. Okay. So from the origin, if I say that along the A, B, and C, I have to see. So the along the A, I can see there is a twofold is there. So I will write twofold. Along the B, I can see there is a twofold, but it is shifted by the amount of 1 by 4 in the direction. So along the Y, there is nothing. So we'll write 1. What about C? So this mark, it's telling that it is a screw axis. Screw axis, it is of the twofold. Since this symbol is there, this is a twofold. And this indication is that it's a screw axis. So we'll write 2, 1. So the location of the origin, the side symmetry of the origin is 2, 1, 2, 1. Similarly, we can go with the one can do this also. So there is a twofold is there along the C. There is a mirror is there. The solid lines are the indication of the mirror. So the along the A, we can say that there is a mirror is there perpendicular to the A axis. So there is a mirror. Perpendicular to B axis, there is a mirror. Right. So there is again a mirror. And the C axis, the twofold is there. It is indicating that yeah, there is a twofold. So we can say that yeah. So the side symmetry of this particular region will be mm2. Let's solve few more questions based on this particular same thing. Over here. F222. Since 222 is there, is written as F2. It means again there is a orthogonal. So again the three position will be along the A. Along the B we'll see what symmetry element is there, and along the C also we'll see what it is there. So along the A, if we talk about along the A, we can see that there is an arrow is there, right? This type of arrow. And this arrow is an indication that yeah, there is a twofold is there. So we'll write the twofold is there along the A. About the B also there is a this particular arrows are there. So we can say again yeah, okay, there is a twofold is there. And what about the C? In the C direction we know that there is a twofold is there along the C axis. So we'll write 2 2. So the side symmetry of the origin over here is 2 2 2. Right, and so on and so forth. One can solve this also. Let's make it very let's quickly solve it. Since it is orthogonal, again along the A, along the B, and along the C, we'll see what are the things available. Along the A, we can see that there is a twofold, so we'll write it is. Along the B, we can see there is a twofold is there, but twofold is shifted by the 1 by 4, or nothing is mentioned at the particular level, like at this particular y-axis. So since nothing is mentioned, we'll write 1. And along this c-axis there is a screw is mentioned, so twofold, and with this particular marks. So the twofold is there, but with the one subscript because it is representing the screw. So the side symmetry of the origin over here is 2 1 2 1 again. Okay. So with that we have solved this particular question, question number 3. Now let's move and let's get to the question number 4. Meanwhile, if there is any doubt, please feel free to ask me. So here is a question number 4. Okay, since it is not clear, so I will dictate it for you. Okay. So we need to do the fill in the blanks in regard to the PMM2. Okay, since the things are not visible over here, so let's, instead of fill in the blanks, we'll write the entire thing for the PMM2. Okay. So let's take a blank page. Take a couple of blank pages and we'll solve over there. Okay. So for this, let's draw this is a space group given to us, right? So the point group corresponding to this particular space group, M M2. Okay. Let's see that how this MM2 look like. So there is a mirror along the A, along the B there is a mirror, and along the C there is a twofold axis. Let us say this is A direction, this is B direction, and we can say that okay, this is a C direction where we are talking about the twofold. Starting with a particular point, let us say over here with a plus sign. What are the things that we need to do? Let's rotate it about the C axis by the twofold. It will get over here. For the more rotation, we'll get to this particular point. Nothing is going to add. Now, let's see what this mirror is going to do. There is a mirror along the B. Sorry, perpendicular to the B, there is a mirror, and perpendicularly there is a mirror. So let's take a mirror about this. What we'll get? It will remain O plus, but handedness will change. Right? So we'll write over something like this. Again, it will be remain plus, but handedness will change. We'll write it something like this. So this is what it is producing. Okay. So this is just a point group. Now let's draw. Let's write the general position diagram. Let's draw the general position diagram. I'm just marking a few reference axes. Nothing more. I'm just dividing them in the quarter. They are not the mirror. They are just the reference line. So here, let us say these are the points. Lattice points are there. Okay, since it is a P type, it is a primitive type. So at the corners of this particular rectangle, there will be the lattice points. Now, same thing, the entire thing which was mm2, which is applied to this particular point, will be applied over here, 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 and here, right? The same entire thing will be generated over here. So let's write that. There is a twofold. So there is a twofold, and there is a mirror. Right. So again the same thing we follow. O plus, it will be rotated by the amount of O plus. Again it will be by 180 degree. Then there is a reflection mirror across this particular axis, perpendicular to the A and perpendicular to the B. There will be the mirror, right? And then we'll get O minus and O minus, so on and so forth. One can do for all the points, and we will get to know that okay, if I let me repeat it for the all the points. So effectively we are seeing that there are the, in this particular unit cell, we can see that there are the 4 points. Effectively 4 points we are able to generate by this particular space group, and that's why we have drawn this particular general position diagram. Now corresponding to this, we also need to write the symmetry operations corresponding to them, right? So let's see how there is a 4 point is generated, right? So the first point, how one can write about the first point, how one can generate the first point. First point can be generated by the one fold of rotation. It will coincide with itself. Now then second point, what about this second point? Let us say this is the second point which we are talking about. This was the first point. Second point one can generate by the operation of twofold of rotation along the z-axis. So there is a twofold, but what is the position of this particular twofold? We can write them as okay, along the x, it is along the z-axis, z-axis. So we will write them as O and Z. That's how one can produce this particular point. What about the other point? Let us say, let's talk about this particular point. Which operation will produce that? So here we are writing the symmetry operation. How one can produce these points? So we can say that okay, it can be produced by the mirror. Starting with the from this particular point itself, how we can produce this point? There is a mirror is there, this particular mirror, and that will produce this particular point. So how to write this particular mirror? So third thing is that there is a mirror. We got to know that okay, yeah, there is a mirror, but what is the position of this particular mirror? So since this mirror is perpendicular to the x-axis, along perpendicular to the A, so it will be written as x coordinate will be 0, y coordinate will be there something, and z coordinate will be there something. And fourth, this point we have generated. Now what about this particular point? This point can be generated from this first point by the mirror along this perpendicular to the b axis. Okay, so this mirror. So we can write them as there is a mirror is there, but the location of mirror is since it is perpendicular to the b axis. So we'll write that okay, it can take any value in the x, any value in the z, but zero will be along the x. Zero will be along the y. And this is how one can write the symmetry operation for PMM2. Now, okay, let's draw its symmetry diagram also. So, about this, there is a twofold. There is a mirror along B. Again, there is a twofold. Right, this twofold will be there. Then there is a mirror. Again, twofold is there. Again, there is a mirror. There is a twofold, and again there is a mirror. Now, what we know. Okay, let's fill it up. That the combination of this two folds with the translation, the interaction of the two fold with the translation will produce the two fold at the middle also. And also at the center. Not only the two fold, the mirror will also interact with the translation, and we know that at half the lattice translation, by which the mirror are separated, there will be the mirror again. For this two mirror also there is a mirror. And with that, this is we have drawn the symmetry diagram. And this was all that we need to write. Okay, but the thing is that now it's not completed yet, our question. The question, if the one which I made, there I also included the positions where we're talking about the multiplicity and the Wyckoff letter and the side symmetry. That is something is left to do. Let's do that part also. For that, we need to take the reference of this particular diagram, general position diagram. So let me draw it over here. Okay, so now let's get started with the. So first of all, what is the side symmetry of the origin? Where the origin is lying. Okay, we need to write the origin. So design line somewhere over here. So again, this is a PMM2 is an orthogonal system, and so we know that the positions, the directions, the viewing direction will be A, B, and C. So along the A, if we see, so what is the things are there which is along the A? There is a mirror is there which is perpendicular to the A-axis, right? So we can see that okay, there is a mirror. So we are talking about this particular mirror which is perpendicular to the A-axis. Then there is a mirror also which is perpendicular to the B-axis. Those are this particular vertical mirrors. And about the C-axis, we know that there is a twofold. Simple twofold. There is no skew, just a simple twofold is there. So we can write. So it is mm2 is a origin where it is lying. Origin is lying on mm2. Now, now let's go with the positions. For positions, first we write the multiplicity. Then we have to write the Wyckoff later. And then after that we have to write the side symmetry. And we will also write the coordinate. So better I separate them. Let's start. So this was already done. Let me keep it aside. So let's start with the one having the maximum symmetry, the origin. Okay. So we can keep them as a, if I keep any point over here. Okay. Let's say my point is lying over here. Let us say this is my point. It will lie over. Then if I apply all the operation mm2, what things I'm going to get is only this much. So for this particular thing, it is contributing to the lattice, corresponding to the unit cell, but just by the amount of 1 by 4. This is also 1 by 4, 1 by 4 and 1 by 4. So effectively, it is 1. The multiplicity for this will be 1. Let us say we are starting with the Wyckoff letter A. From A will build up all the things. And what is the side symmetry of this? It is M2. Okay. And the coordinate of this particular point, it is nothing but O, and along the z-axis. Z-axis can take any value among this. So about this particular coordinate will have this particular symmetries, mm2. Now, there are a few more things. If I place my point over here, this side itself is having the symmetry. What symmetry this particular point is having, this particular side is having. This is also a special side because there is a twofold is there is a mirror is there along here and along here also. So this is exactly same as this particular point, right? So this side is same as this particular side from the point of view of the symmetry. Okay. And again, let us say I am placing my point over here. Let us say this is just a replica of this. I am placing my point over here at this particular side. It will rotate by 90 degree. Sorry, it will rotate by 180 degree about the Z. Again, it will remain as it is. Right. It will be reflected back by this particular mirror. If I apply the remaining operations, it will get over here. Right. So we can see that effectively this is contributing by the amount of 1 by 2. This is contributing by the amount of 1 by 2. So effectively they are contributing by the amount of 1. So their multiplicity is again 1. The side symmetry is M2 because mirror is there perpendicular to the x-axis. About this particular side also we can see that the perpendicular to the x-axis there is a mirror, perpendicular to the y-axis there is a mirror, and along the z-axis there is a twofold. So exactly the same side symmetry. Let us say we are giving the Wyckoff letter to be the B. What will be the coordinate of this particular point? Okay, let's find that. So here, x is 0. Okay, starting from this is origin, this is a x-axis, this is y-axis. So since the point is lying on the y-axis, so the x coordinate is 0. Y coordinate we can say it will be 1 by 2, right? And the z coordinate can be anything, because this mirror, okay, this particular mirror, and the two-fold, they will form they are intersecting along the z-axis. So all the points of that particular intersection along the z-axis will be considered. We deal with this. Now, similarly, we'll go with this particular point. This is done. This done means these points are also done. These points are done. This done means this is also done. Now this point is remaining. Let's talk about this. So if I place any point, forget that there is something over here. Now we are applying the same thing to this particular point. Again, rotation by twofold will bring this particular point to itself, right? About this particular z axis. But there is a mirror in between. It will reflect over here, and we can say that okay, we are going to produce the some point over here. So again, the contribution will be by the amount of 1 by 2, 1 by 2. Effectively, they will contribute 1. So multiplicity again will be 1. Wyckoff letter, let's move ahead with the Wyckoff letter and we can see we're getting to the C. The side symmetry is still mm2, because here we can see that there is a mirror which is perpendicular to the x-axis. There is a mirror perpendicular to the y-axis, and also there is a twofold of rotation about the z-axis. And the position of this particular point will be, since it is lying on the x-axis, so the y coordinate will be 0, x coordinate will be 1 by 2, because this side symmetry is only applicable at the half position. This is this particular point in between over here. This is not having the same side symmetry. Okay, this is having the different side symmetry. We'll see what it is. Along the z, it can take any value. Okay, that's how it is. So now we are done with this point. So similarly, we are done with this also. Now this is remaining at the center. So at the center, if I place any point, this mirror is not going to do anything. This mirror is also not going to do anything. Like the point will remain as it is. And along the z also, if I rotate by 180 degree, twofold of rotation, the point will remain as it is. And it's not going to change. So the effectively, it is not producing any other point other than itself. It is coinciding with itself. So in the unit cell, only one point is there corresponding to this particular site. Okay. So the multiplicity again here is a 1. Wyckoff letter, let's move ahead and we can write them as a D. Now the side symmetry is again, we can see that about this particular point, there is a twofold along the z-axis. Mirror is there perpendicular to the y-axis and z-axis, y-axis and x-axis. The mirror is there perpendicular to the x-axis and y-axis. So again, the side symmetry is mm2, and the coordinate of the point will be, this time it is along the axis is 1 by 2. Along the axis it is 1 by 2, and along the z it is 1 by 2. And again, the z can be anything. And that's all. So we are done with this particular type of sides operations, side symmetry. So all of them are over, right? Is there anything left? Is there any other different types of side symmetries there apart from this? So we know that there are mirrors are available to us. Okay. So there is a mirror. We can place our point onto this particular side also. Mirror is there. So this is also a special side. Here it is also a mirror. This is also a special side. Right. This is also a mirror. This is also a special side, and this is also a mirror. So anywhere along this, if I place, they all of them are our special site. Okay, so let me write one of them, and remaining part one can do in the similar manner. Okay, so let us say which point should I choose this time? Over here. Okay, yeah. So okay, let's place our anywhere we can choose. Let us say we are going with this particular point. So let me write somewhere. Let me draw somewhere. Better to take a next page. This will go in rough. Let's say this. I chose this particular point. There are the two folds are there, and these are the mirrors. And this is my point. Now, what are the things gonna happen? If I take a two-fold about this particular, we are going to this go over here. About this particular mirror, it will be reflected over here. This will be reflected over here. So effectively, this is what we are going to produce. Alright. We can see that this is going to contribute 1 by 2, 1 by 2, 1 by 2, and 1 by 2 to our unit cell. So effectively, there are the two. Effective contribution is 2. So multiplicity of this particular site, if I place a point on this particular site, it is 2. Let's move ahead in the Wyckoff operator, and we can say that, okay, we can write from D, we can write it to the. Now, what is the side symmetry of this particular point? So about this particular point, there is no two-fold along the C. So C is not having anything. So there are the three places are there. C is not having anything. We'll write dot. We'll write dot over here. What this particular point? It is lying on this particular mirror, which is perpendicular to the B axis. Okay. So we can say at the so along the C there was nothing. B perpendicular to B there is a mirror. Okay, we'll write a mirror. So this particular side is a mirror, which is perpendicular to the B. Now, what about A? A is not having anything over here, right? A is having the mirror over here, but not at this particular point. So again, we'll write dot. So the side symmetry of this particular point will be dot M dot. Now, what about the coordinate? About the x, it can be anything. But about the y coordinate is always 0 since it is lying on this particular point. So about the x, it can be anything. So we'll write x. About the y, it is 0. And about the z also, since this is a mirror, it can be anything. So x, o, z. Right. So that's how one can proceed this further. Like from this mirror, one can now choose this particular mirror. One can choose this mirror and this mirror also. Okay. And choosing all these four mirror, one can go with that. Okay. Again, the E, F, G, and H will be created. And then at the end, we won't be left with any other symmetry because everything will be over. And then we'll say that, okay, let's go with the general point. And now write this for that particular point. And we know from here that general position is going to produce the 4 point with this particular symmetry operation. Okay. And that's how one can start proceeding from here. Just by knowing the space group, one can draw the entire part. Okay. So one can complete this entire section. It's easy from now onwards. Like, just we have to take a point on the each of the symmetry elements, and corresponding to we'll write their sides and multiplicity, Wyckoff letter, and coordinates. It is very easy. Okay. So now let's move to the next question. So I've covered the multiple question while solving this, since it is not visible to us properly. So we'll cover the entire international table for this particular space group. So we can skip the question which I made for a time being. Here it is written about the P22 space group. Again, the same thing. Whatever we have done with the PMM2, we have to do with the this also. So, so we can one can do this entire part following the same procedure what we have followed in the PMM2. Okay, so you can consider that to be the like extra question beneficial for you that one can proceed it. Let's move to the next different type of question. Question number 6. So here we have to write down the coordinate triplet of the symmetry operation of the orthorhombic crystal system. So what symmetry operation is that? X bar plus 1 by 2. That is a translation by the 1 by 2. Y is remaining y and z is remaining by 2. So how do we write the symmetry operation for this? So there will be the matrix part will be there, and there will be the column part. Matrix part we can write that x will be x has got to the minus 1, right? X just changes position. So sign it changes sign. So x minus from 1 it will become minus 1. Remaining part will be 0, 0, and there is a translation is there along the x, that is by the amount of 1 by 2. For the y it is O, 1, O, and there is no translation, so 0 over here. For the z, we can write the minus 1, sorry, 0, 0, minus 1, and 1 by 2 of the translation is there. So the question was, it was just to write this. But now if we ask ourselves what this particular thing is representing, like from the x, y, and z, from the x, y, and z, how one can have got to this particular coordinates? By what symmetry operations they could have got over here? In order to find that, let's deal with this particular first. Let's deal with this matrix part. So the determinant of this particular matrix, if one found that the determinant will be plus 1, right? So we can see that from here that yeah, it is a type 1 operation. There is no change in handedness. Further, what about the trace? Let's talk about the trace. Trace is a addition of the diagonal elements, that is minus 1 plus 1 minus of 1. It will be equal to the 2 cos theta plus 1. We'll find the what is the sense of rotation it is having. What is the fold of rotation it is having. So this will be cancelled out with each other. We will get 2 cos theta plus 1 will be equal to the minus of 1, and with that we'll get cos theta will be equal to the minus of 1. So we can find that theta is 180 degree. So there is a fold of rotation, two-fold rotation. This is a type 1 operation also, and the trace is also there. So we got to know that this is a two-fold, but what is the position of this particular two-fold? Or whether it's true or not. How to find that? For that we'll take help of this particular translation. Okay. So let's see uh, for this particular operations which we have right. This one, O1, O minus of 1. What what are the set of point which this particular operation is leaving to be the invariant? And those will be the set of points will those formation those set of point, whether it's forming the twofold, sorry, whether it's forming the line mirror or what it is forming. Okay, so let's see that x, y and z. I applied this particular operation to the x, y, z such that the end of result is remaining as it is, same x, y and z. So let's try to solve this. So the x will be equal to the, let's just multiplication of this with the x, this, and then the addition will follow. So we'll get minus of x plus 1 by 2. y is, y will remain as it is, y, right? This will multiply with this and addition of 0. Yeah, it will remain y. Regarding the z, z will become minus of z plus of 1 by 2. So if we solve this, what we are getting from here, that x will be equal to the 1 by 4. Z is equal to the 1 by 4. And the y is remaining as it is, like y is equal to the y. So only one thing is invariant. Sorry, one thing is like it can take any value. Remaining things are fixed. X and Z are fixed. So we can say that there is a twofold is there at the location where x is 1 by 4, y can be anything, and z is again 1 by 4. So let's draw the orthogonal system over here. So the 1 by 4, if this entire is B, so 1 by 4 will lie somewhere over here. And again 1 by 4 will lie over here. So we can say that, okay, the twofold is there some over here. And that's what this particular symmetry operations is telling, like how one can get from xyz to the this particular set of triplet. And so with that we have solved the all the questions which we was supposed to, which I was intended to solve over here. If there is any doubt, please let me know. If there is no, we can wrap up this particular class. Okay, so with that, let's complete our today's discussion, and let's meet up again in the upcoming doubt session.